Previously, I mentioned that parallel processing and distribution styles weren't the only contributing factor to the speed of a Redshift data warehouse. Amazon Redshift also takes advantage of several other approaches to data storage convenient to the OLAP-type workloads of a data warehouse. Namely, it's architected for column-oriented storage. So consider the following example. In a traditional RDBMS like MySQL, storage blocks, usually called pages, are row-oriented. So you might have a table that stores employee info, social security numbers, addresses, and salary across one set of rows. If I wanted to get the average salary of all employees, the query engine has to read in all pages that contain salary info into memory in order to calculate the average. Meaning it's potentially reading in a lot of columns into memory that it doesn't actually care about as it's getting each row. In a column-based storage architecture, all data read into memory is relevant. It can bring in blocks of the salary column, ignoring all other data that isn't directly related to the query. This approach is so effective that column-oriented databases have really been gaining popularity lately, and products such as Microsoft SQL Server have added column-oriented indexes to make these types of queries much faster. So this might bring up the question, why aren't all RDBMSs architected this way? Well, largely because they must balance the benefits of an OLTP design versus an OLAP design. Amazon Redshift is focused on data warehousing, decidedly OLAP. A database like Microsoft SQL Server stores data page blocks in 8 kilobyte chunks. This makes latches, locks, updates, reads, and all the activities of an active OLTP system much more efficient. Meanwhile, it supports effective OLAP activities through other means. Amazon Redshift stores its column-oriented blocks in 1 meg chunks. Now, smaller queries may still read in more data than needed if they are restricted by highly focused where clauses, but large aggregates, something much more common to data warehouses, benefit from this simpler approach to storage. Now, this storage approach means you do have to let go of some of the concepts that you're probably very familiar with if you have a lot of experience with a traditional RDBMS. A perfect example is the concept of a clustered index and a non-clustered index. Redshift has no form of indexing. Now, this may come as a complete shock to you. How can a relational database claim to be fast if it doesn't support indexing? Again, architecturally, it's a different approach that relies on scale-out parallel processing, which in a purely OLAP environment really shines. If you're looking for a database that has a heavy amount of CRUD traffic, create, read, update, and delete, and lots of individual lookups, well, Redshift might not be a very good choice for you. Amazon has a lot of other databases through its RDS platforms, SQL Server, MySQL, Postgres, just to name a few, as well as NoSQL options. They would potentially be much better at a typical OLTP system. If you're looking for terabyte to petabyte scale aggregates, averages, and legitimate OLAP workloads, however, you have come to the right place. Now, small side note here. Despite the fact that there is no clustered index, Redshift does support ordering table rows on disk in the same manner as a clustered index, or at least a similar manner. Redshift refers to this as a sort key. You declare a sort key exactly the same way we declared a primary key or a distribution key in our previous demo. Again, however, you need to design this up front. You can't come in and add a sort key to a table after it's been built and populated. Also, you only get the one sort key. There is no concept of non-clustered indexes that would allow you to come and add additional sorts. As we finish building up our complete data warehouse schema, I'll include some sort keys on those demo scripts that you can download and inspect. And maybe you might come up with sort keys that you think are more appropriate. There will be a follow-up course here on Pluralsight, hopefully published very shortly after this one is, that will delve deeper into the performance aspects of Amazon Redshift. And in that course, we'll talk a lot more about sort keys, the internals of tables, and some of those items there. So I encourage you to keep an eye out for it once you are finished with this course.